Our strategy is to accelerate deep learning everywhere, for every platform, for every market, for every single industry. First, accelerating the cloud. The cloud is the fastest, the best way, the early adopters of deep learning, and bring this technology to users all over the world. However, there are many companies that need to have resident on-premise computing, and our OEM partners will take deep learning accelerated servers all over the world on our behalf. We have it in the cloud. We now have OEM servers for IT. However, there's still some users that would like to have access to deep learning that this is simply not fast enough. They would like to have the fastest, the latest technology. They would like to have it integrated. They would like to make sure that all the software is working perfectly and tuned and fully accelerated. The frameworks that they will use will be of all different types. And they are the early adopters. They're the data scientists. They're the researchers. And they need something now. So we decided to build the most advanced computer that anyone has ever built. We decided to build the Nvidia Dgx-1, the world's first deep learning supercomputer. It is engineered top to bottom for deep learning. It's 170 teraflops in a box. On a rack, it's 2 petaflops. A 2 petaflops computer for deep learning has 8 GPUs, 8 Tesla P100s, organized in a hybrid cube mesh. It accelerates all the major AI frameworks. Let's take a look inside. The densest computing node ever made. 3,200 watts, 8 GPUs, organized in a hybrid cube mesh. Getting data in and out of this machine, because it processes data so fast, is vitally important. And so we have 7 terabytes of streaming SSDs. We have quad InfiniBand and dual 10 gigabit Ethernet. Connected together, this is one beast of a machine. One single node, 170 teraflop machine, the densest computer ever made. Incredible, incredible. Now let me compare it to something that is available every day. A dual Xeon processor, for example, if we added up all the flops between CPU and GPU, is about 3 teraflops. The total amount of aggregate bandwidth that's inside connecting processors is 76 gigabytes per second, which is basically the QPI link. It takes 150 hours for a server. 150 hours. 150 hours. Basically almost 2 weeks to train AlexNet. So if you had a server, it takes almost 2 weeks to train, 150 hours. Dgx-1, 170 teraflops in one box. 768 gigabytes per second of aggregate bandwidth connecting the processors to each other. And if you wanted to train AlexNet, it's not 2 weeks. It's 2 hours. 2 hours to train AlexNet. 2 hours to train a network. Now, the part that's really quite shocking is this. Because when you scale out using traditional off-the-shelf high-performance computing architectures, the interconnect, the communications between the processors becomes such a large burden as you synchronize the nodes. Each additional node that you add gives you diminishing results. And over time, as you scale out, the speed up is no longer great. It would take over 250 nodes, to keep up with one Dgx-1. Over 250 nodes to keep up with one Dgx-1. Unbelievable. It's like having a data center in a box. 250 servers in a box. Last year, I predicted that 1 year from now, because I realized that I had already realized we're all in on Pascal, that we were all in on NVLink, that we were all in on the miracles I talked about, that 1 year later, I expect to see a 10x speed up. A 10x speed up year over year. Well, ladies and gentlemen, I'm delighted to announced that we achieved a 12x speed up year over year. The fastest computer in the world for deep learning at the time was 4 Maxwell GPUs. At GTC 2015, we were so proud. We were rightfully proud to announce that we could train a network that used to take a month and now do it literally in 25 hours in one day. Today, we can now do it in 2 hours. 1.33 billion images per day. This particular machine just cranks through it. Now imagine you're a researcher. Your work is so important. Your need to discover the next big thing so great. The stakes of your work so great. The laboratory filled with amazing engineers. The world's best of its kind, trying to do a deep neural net design. How could it be possible that you can tolerate the training times necessary, the training times that would take days and weeks and months? They need the fastest supercomputer in the world at their fingertips. And that's why we built the Nvidia Dgx-1. 12 times speed up year over year.